Welcome to the Desert Research Institute. Today I'm going to be giving you a tour of what we call the REDD facility. REDD stands for Renewable Energy Deployment and Display. And what we have here is a potentially off-grid facility consisting of a residence that's 1,200 square feet and a workshop that's 600 square feet. We call it potentially off-grid because it is focused on doing research. No one's actually living in it, and we like the capability of being able to take certain parts of the system down so we can implement new technologies into it. The whole house and workshop are instrumented, and we're collecting data 24/7, and we also have the capability to add a lot of controls. What you're seeing here are solar thermal panels that are on the house and a rack in front of it. And these are used to both heat and cool the house. The solar thermal panels on the rack down here is a conventional solar thermal system made by a company called Viessmann. This would be what your contractor would install in your house. The collectors consist of copper pipes that run a glycol mixture with water through them, and basically the sun heats up that mixture. That mixture can then go inside the house and go through a heat exchanger to heat up the water that you would use for showering, for cooking, or in our case, for even heating the building. The collectors on the roof is a local company here in Sparks, Nevada called Sunvelope Solar. And that is an envelope design which is meant to be able to freeze or boil. This allows you to not have to use glycol, to not have to use a heat exchanger. You can take the water out of your pre-existing hot water tank, send it up to the collectors, heat up that water, and then circulate that through your house. We're now down in the crawl space of the REDD house, and these are our two hot water tanks that we're currently using to store the hot water generated through the solar thermal collectors. This tank over here is used specifically for the Viessmann collectors. And as you can see, we require this heat exchanger, several pumps, as we have to transfer the energy from the glycol mixture to the water that's in the tank. This tank here is for our Sunvelope system. As you can see, there are no heat exchangers required. There's just a pump back here that pumps the water directly out of this tank up to the roof and back down to it. Each of these tanks are 120 gallons. This is sufficient for heating the building in winter, and it's almost sufficient for cooling in summer using an absorption chiller. For this upcoming summer, we have 2 more tanks that we will install right here, so we'll double our capacity, which will allow us to more than sufficiently heat and cool the building all year. What we're looking at now is what's called an absorption chiller, and this is what we use to cool the building. This is similar to a conventional central air unit that you would have on your house. The difference is that this is a lot more efficient because rather than having to pump a vapor that your refrigerant is in, we can now take that vapor, we can absorb it into hot water that's generated through our solar thermal panels, and we can pump water instead of a vapor, which is a much more efficient process. So what we do with this is that refrigerant can be absorbed in the water, transferred over to the heat exchanger to be cooled the refrigerant, and then it can be used to take the energy out of cooling water that's being used. The bottom line is if we can generate solar hot water at 150 degrees, with this unit we can generate cold water between 42 and 45 degrees. That cold water can then be passed over to a heat exchanger that's built into the furnace. So the blower in the furnace can turn on, we can pass the air from the building across this cold heat exchanger now, and we can cool the facility. When we're in heating mode, it's a similar process, except we bypass the absorption chiller. We pass that hot water straight through to a heat exchanger in the furnace, and we blow the air through. So it is a centralized system. You don't have to make any modifications to your furnace. All we've done is added on a few heat exchangers.